Today I'm gonna teach you how to solve Rubik's Cube. You know, there are so many formulas out there, very complicated stuff, turn left, turn right, all of that. No, screw that. I found a very easy way to do that in 3 easy steps. Easy peasy lemon squeezy. Super easy to do. If you have Rubik's Cube at your home, definitely pause this video, bring it like to the screen of the computer. We're gonna solve it together. Okay, ready? Okay, step number 1. You need to solve any of the colors. Let's say red. Okay, let's say this red. Okay, and then second step, you need to learn filmmaking, because when you do filmmaking, you can do something like this. Now, oh, hold on. That's actually it. Sorry. Lecture number 23. I hope you guys doing well. I'm very excited about the fact that the semester is almost over. I hope you're excited too. And especially if you guys are graduating, that's actually super amazing news, right? Well, I'm not sure if you're like concerned about coronavirus at all, or like what are your thoughts in your mind. Let me know in the comments below. But yeah, so the semester is almost over. There is like a couple of lectures, and then we'll get to the final exam. Today I want to show you like one of the kind of an entertaining algorithm, not an algorithm, but thing, something interesting for you. It's called stack smashing. Stack smashing. Okay, that's one of the like cybersecurity things, and it's actually based on the pointers, and that's what we're actually talking about a lot: pointers and how to manage memory, all that stuff. Okay, so let's get to the notes. Stack smashing. Okay, so here's the idea. Here's how it works. So the lack of bounds checking on array subscripts and pointer arithmetic is a major source of bugs. Okay, yeah, so if you have again, technically an array is just a pointer to some kind of address, and then after that address, if you have, for example, array of 5, what computer is doing, like Java compiler or like any runtime machine, Java virtual machine, what it's doing, it's adding like 5 integers, which is 5 times 4 bytes, to the initial address of that array. Okay, and it's possible, if you're not doing it correctly, especially in older languages like C, that you would go out of bounds and you would go somewhere where you should not be getting into. Okay, major source of bugs. Okay, bugs and security problems in languages like C. Okay. Many of the most famous internet viruses have propagated by means of so-called stack smashing, okay, which is in its turn a particularly nasty form of buffer overflow. So you probably remember the Stack Overflow, right? So that's kind of like, no, it's not well, no, it's not similar. Buffer overflow attack. Okay, buffer overflow attack. So buffer overflow attack is also a famous attack, or it's you would say the series of problems of cybersecurity flaws of attacks. Okay, and stack smashing is like one particular nasty thing there. Okay, so consider a very small and naive C code. A naive piece of C code. Okay, so let's write some code in C. Let me go through to the new line. Okay, so here's what we're trying to do. We're trying to get, so int, return integer, get account number. Okay, so file pointer s. Okay, the idea is this: the user provides the pointer to the string, well, to the file, right? We're reading from the input string, we're reading from the file text, okay, which is the account number or some kind of number, and then what we do, we convert that into an integer and we return back an integer. So that's the idea. Okay, so what do? We create a character buffer. Buff. Okay, 100. So which means we create an array. By the way, in C there are no strings. In C++ there are vectors and there are like a couple of things you can do, but in C there are no strings. That's why in C a string would be an array to the first character. No. The way strings are implemented in C is that you just create an array of characters and then you pass the address of that array. Okay. So which means that, for example, if I have something like this, if let's say that's my RAM, somewhere over here is my string, right, which is basically a couple of like numbers, and then I would have maybe, okay, and then let's say I want to type something in, I don't know, like for example 1 2 3, okay, and then in order to, since there are no strings, right, so like you have numbers, how do you know when the string ends? Then there is a special keyword which is \0, I think, right now, yeah, 0, okay, yeah, \0, okay, so that means in the ASCII code end of the string, okay, in this case to C it would signify my string is 1 2 3 as characters. Anyway, so we created an array of characters called buff, 100 characters. Why 100 characters? Just because supposedly any string should be less than 100 characters. Like a bank account number should be less than 100 characters, right? Which is already, as you can guess, kind of a mistake. Anyway, then we created a pointer, right? So char p is equal to buff. Okay, so if we say buff of 1, that means the number of the first position of buff, like our character, right? But in C, if we just say buff without like the brackets and without anything in it, that gives us the pointer to the entire array, which means the address of the first element of the character array. Okay, so in other words, we create an a pointer which points to the array buff, and then we do okay, okay, so here's what we do. Star p is equal to get cs, okay, and then we do that while star p, which means plus, okay, is not equal to n, okay, star p is equal to \0, okay, which means that's the end of the string, right? And then we convert the string which we have in p, right? In buff, right? And then so basically into number. So return a get a to I, right? A to I, and then here we say buff. Okay, so here's how it works. This code. So supposedly it should technically work in C. I know, like it's very yeah. So instead of like in Java, you would do input dot next int. So that's what it would look like in C. So as you can see, it's very complicated. Okay, so here's how it works. Okay, so where would this start? So I have again, I have some RAM. Okay, so let's say I create that buff, okay, which is an array of 100 characters. Okay. An array of 100 characters. Yeah, so then I create a pointer to a character p, okay, and it points to the same location as buff, okay, and then I do star p get character from s, okay, so get c means get char, get character, that's a special function in C as well, and then where from s, and s is a pointer to a file which is like a stream of tokens. But anyway, get character from s means extract one character from the token, from the stream of characters, okay, and then assign it to P, and P points to to different locations. Why? Because you see we do here P plus plus, okay, so we increment P plus plus, sorry, we do star P, okay, if it's not equal to N, okay, we increment P. It's you can actually you can do that in Java as well, like this code, right? So what it does star P, okay, if the last character which was scanned, if it's not a new line, which would signify the end of the string, right? If it's not a new line, then we do P plus plus, which means we increment the address, okay? So now P basically points to different location in the buffer, okay? And then if once we're done, okay, so once we scanned the new line, we go over here and we say star P 0/0, which means end of the string, and then we're going to return A to I buff. Okay, so A to I buff, what it's going to do, it's going to go to the location of buff, right? It's going to take a look at buff as an array, and it's going to try to convert that whatever that number from an array of characters into an integer, okay? Because technically, okay, so if in the file, right, hope you remember that you have array of characters, which means you would probably have in the file, I don't know, let's say somewhere here in the file you have 1, 2, 4, okay, so that means 124. So you scan them from the file as 1, 2, 4. So those 1, 2, 4 are being placed over here, 1, 2, and then 4. And then it's going to add, according to this algorithm, it's going to add /0 over here. Okay, and then return A to I buff. That's a C function which is going to scan buff, which is 1, 2, 4, and it's going to stop at \0 because that signifies the end of the string. And then it's going to convert 1, 2, 4 into a number 124. That's the idea. Okay, so can you guess what's wrong here? Technically that should work, but there is some kind of a problem. And the problem, which is, I kind of already mentioned that, is this. For some reason we assume that everything is going to stop after 100 characters. But what if that number which a person is trying to convert, which is person is providing here, doesn't stop at 100 characters? What if it actually goes longer? What if it takes more characters? Or what if he just comes up with a number of 100 characters, but what he's actually trying to do is somewhere outside? Okay, so here's the problem. Here's the problem. Hey, if the stream provides more than 100 characters without \n, those characters will override memory beyond the buff, okay? So here's what's gonna happen. Let's erase this, and let me draw one more time. Let's say that is a stack. That's the stack. Okay. So the stack grows upwards. Well, it technically grows downwards, but it's flipped, right? Yeah. Anyway, so you have buff, right? Because you declared it locally, so it's going to be located on the stack. Buff. Okay. And then, so that's our buff. Okay. And then at some point over here, you're gonna have the return address. Okay. So the buff. buffer has been allocated. Here we have only the memory enough to store 100 characters, okay? But if the person goes beyond 100 characters, what's going to happen? It's going to override this memory, and at some point, which can be calculated when exactly it happens. So how many characters do you need to put in the buffer such that it will get to the return address, such that it will override the return address. Okay. And yeah. So in this case, if we here's how it works. The person who's trying the villain who's trying to attack the computer, what he does, he provides a very, very long string of to the buffer, right? This buffer. It's not 100 characters, it's a lot more. He calculates how many characters he needs to put in such that it will overflow the buffer, plus overflow the section in the middle between the buffer and the return address, all those local variables. Well, that's one of them. All the temporaries, all that stuff. So he knows how much space does it need to override that, and then it also overrides the return address, and that's where the frame pointer points. I think it almost points at the return address. Okay, so in other words, when the stream is being scanned, it overrides the buffer, the stuff behind the buffer, below the buffer, and it also overrides the return address too, and the villain knows what to override it to. And in that case, when that code finishes, when that method finishes up, right, it's going to return to the method which called it. But how does it know which method called it? By the return address. And here in the return address, the villain put his own address of the code of the virus which he wants to execute. So that's why the computer is going to finish it up here, right? It's not going to convert anything to anything. It's going to return an error. That's cool, but it's not going to stop. And then it's going to, as it exits the program, it returns, right? It's going to return to this address, which has already been overflown to the villain's virus. Okay. Yeah. And then it's going to, let's say, I don't know, over here somewhere there is a virus. Okay, some over here. That's the virus. Okay. Yeah, and that's why, after this, at the return address, it's going to ask to return over here, exactly to the virus. Okay, and then the virus will be automatically executed, and compiler, not the compiler, but the runtime environment, and the operating system is going to think that virus is not going to notice that. It's going to think that that virus actually was the stuff which was called before this method was called. Hope it makes sense. Anyway, that's why I'm going to provide you actually a verbal explanation of how it works. Buff, okay. Buff. A careful attacker may be able to invent a string whose bits include both a sequence of valid machine instructions and a replacement value for the subroutine's return address. Okay, so yeah, so the attacker he transforms the buffer, okay, that stream of characters such that it's going to replace the return address, and then the computer is going to return to the virus instead of the actual return address, which called that method get account number. Okay, when the routine attempts to return, it will jump into attacker's instruction instead. Okay, which means that the attacker's instruction, which is the virus, is going to be automatically executed, because again the operating system thinks that that's actually a safe instruction. Okay, cool. Yeah. So, and then the question is, how do you prevent it? How can you prevent stack smashing? Okay, so it can be prevented by what? By not assuming that that get account number is going to be only 100 characters at most. Okay, so if you basically check, or if you stop the whole operation after you reach the 99th character in the buff, in this case, like, this entire thing will be prevented. So it can be prevented by manually checking array bounds in C. Yeah, and of course in Java it's a lot easier to convert a number character into number. There are like special methods, right? We can, or Java virtual machine already knows automatically how to convert a number into character into number, all that stuff. Okay, cool. Jump to trackers. Okay, hope you guys enjoyed this lecture. It was fairly short. I'll see you. No, I think, yeah, I'll definitely record a farewell video, kind of the before the end of the semester. But I think on Thursday I will also provide the list of things like to read and to watch, and you will submit me the notes, or do some short exercise. Okay, I'll see you guys next time. Stay safe. Bye bye.